It's Curious Kids Weekend Picks, where a kid from the Curious Kids Club gets to pick the episode. So, what episode are we going to hear today?
Hi, my name is Alfie, and my favourite episode of the Curious Kids Club is how calculators work. It doesn't use base 10, it uses base 2. So cool. It is my favourite episode. Thank you.
Hi, welcome to Curious Kids Every Day. I'm Josh. How are you doing today? It's so good to hear from you. Okay, if you make it through this whole episode, I think you might be the most curious kid of all. My day started like most days do. I chose a topic that I wanted to make a Curious Kids Every Day episode about, and then I started doing research. Today's question was, how do calculators work? But you know what I found out? I found out that calculators are a lot more complicated than I thought. And in ways that were almost impossible for my mind to understand. Do you like to use calculators? I am amazed by calculators. It's incredible to me that you can just punch some numbers in and instantly add them or subtract them or multiply or divide. How does that little device possibly know the answer to any math problem you type in? Well, that's what I started my day trying to figure out. And I don't really know exactly how I'm going to try to explain this, because it's pretty crazy, guys. But I'm going to do my best, okay? I'm gonna need you to grab a pencil and paper for this episode. You're gonna need it. If you finish this episode and even learn a little bit, just a tiny bit, about how calculators work, you are going to know more about calculators than most grown-ups do. Okay, are you ready for this? Get that pencil and paper ready. Today, we're going to learn how calculators work. Here is the most important thing you need to understand about how calculators work. A calculator works by doing two things. One, turning numbers into tiny electrical signals. And two, following very basic rules over and over very, very fast. So first, let's talk about how numbers live inside a calculator. Inside a calculator, numbers are not written the way that we write them. Calculators have their own language they use for numbers. Now, do you know what the name of our number system is? You might maybe have heard this term before. It's called base 10. Can you say base 10? We use 10 digits. Think about it. Every single number that we write is written using just 10 digits. Do you know what the 10 digits are? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. Every number you have ever written has been some combination of those 10 digits. When we write a big number, each place is 10 times bigger than the one to its right. Here, grab your pencil and write the number 21. Can you do that? 2, 1. The number on the left, the 2, that's in the tens place. We call that the tens place. That means it's 2 times 10, which is 20. Okay, so that 2 means 20. And then the number on the right, the 1, that's in the ones place. So it just means what the number is, 1. So it's 20 plus 1, 21. That's why when you see a 2 and a 1 next to each other like that, we call it 21. This is all base 10. And you're probably thinking, I thought that was what all numbers were. And yes, but no. See, that system works great for humans, but now I'm about to blow your mind. Calculators and computers use something different. And we call that system base 2. Can you say base 2? Base 10 has how many digits? Right, 10. Now, how many digits do you think base 2 has? Yep, only 2. Every number that you could possibly imagine can be represented with just 2 symbols in base 2. And we usually write them as 0 and 1. But they aren't actually numbers the way we normally think of numbers. They're really just symbols that mean on and off. Okay, so let's go back to the number 21. Now, in base 2, we don't write 21 like that, 2, 1. No, that's not how we do it, because we only use zeros and ones. The number 21 in base 2 is written like this. Are you ready? 1, 0, 1, 0, 1. That is how you write the number 21 in base 2. It's almost like a secret code. You want to know how it works? I can show you. Okay, this is so cool. Write down these numbers. 1, 0, 1, 0, 1. Okay, did you write it down? Now, start on the right, the last number you wrote. Underneath that 1, I want you to write a 1. All right, so underneath the 1, write a 1. Then, underneath the 0 that is next to that 1, I want you to write a 2. Then, underneath the next number, I want you to write a 4. Then, under the next number, I want you to write an 8. And then finally, under the last number, the one the furthest to the left, I want you to write a 16. Now, read those numbers from right to left. 1, 2, 4, 8, 16. Are these numbers random? Nope. This is how base 2 works. Each one of these numbers is twice the number before it. So 1 plus 1 equals 2. 2 plus 2 equals 4. 4 plus 4 equals 8. And 8 plus 8 equals, yep, you got it, 16. Now, look at the 10101 above those numbers. I don't want you to think about these as numbers. I want you to think about them as yes or no. So 1 means yes, and 0 means no. So let's go down the line, and every number that equals yes, let's circle that one, okay? So 16, yes or no? Is there a 1 above it or a 0? There's a 1, and 1 equals yes, so let's circle the 16. Okay, then, what about the 8? Yes or no? Nope. Okay, skip that one. Go to the 4. Yes or no? Yes, there's a 1 there. Circle that one. Okay, go to the 2. Yes or no? Nope, skip that one. And then how about the 1? Yes or no? Yep, there's a 1 above it. Circle that one. Okay, so what numbers did we circle? 16, 4, and 1. Well, let's add them up. 16 plus 4, that equals 20. And then 20 plus 1 equals 21. That's why 21 in base 2 is written 10101. Now, I know what you're thinking. Why on earth would you do math like that? There's a very, very good reason that calculators use base 2. Do you remember when we learned about computers and we talked about the two numbers that computers use to do everything? We call it binary. Do you remember what those two numbers are? Yep, 0 and 1. Binary is base 2. Zeros and ones. So, when you punch the number 5 on a calculator, the calculator doesn't think 5. All that's happening is that you are closing a tiny electrical switch inside the calculator. See, inside the calculator, there is a thin grid of wires. Each button connects a specific path in that grid. When you hit 5, the binary that the calculator registers is 101. And every number has its own binary code. Now, here's the crazy thing about calculators. They're not actually calculating big numbers as big numbers. See, inside the calculator, there's a tiny computer chip. It doesn't understand big numbers. It only follows a few tiny rules. And here they are. Are you ready? 0 plus 0 makes 0. 0 plus 1 makes 1. And 1 plus 1 makes 10. Wait, what? 10? Yep. That last one is important. In base 2, 10 means to write down a 0 and carry a 1 to the next place to the left. I'm not going to explain all that for now, but just believe me when I say that in base 2, 1 plus 1 equals 10. And it actually works. I tested it myself. And if later on in the episode I ask you what 1 plus 1 is in binary, remember to tell me that the answer is 10. Okay? I'm going to quiz you on this later. 1 plus 1 equals what? 10. But only in binary. When a calculator adds two numbers, it lines them up and starts on the right. It adds one place at a time, follows the tiny rules, carries what's needed, and moves left. It keeps doing this until it reaches the end. 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 0, 0, 0. The calculator never thinks about powers of 2 while it adds. The places already have meaning because of where they are. The calculator is just following the rules and letting the places do their job. Now, once the calculator finishes the math, it turns the answer back into the kind of number that we recognize and lights up the screen to show it. So as far as we know, calculators were using base 10 the whole time. But if you actually understand what a calculator is doing underneath those buttons, it's actually doing it in base 2. It's doing it in binary, and then just spitting it back out to us as base 10, the numbers we recognize. Do you want to try this and see how it works? Do you want to solve a problem the way that a calculator does? Let's try it. Let's try it with 2 plus 2. What is 2 plus 2? Right, we already know what the answer is, but let's see if we can figure out that answer doing it the way a calculator does. Okay, first, the calculator doesn't see the number 2 the way that we do, right? Inside the calculator, numbers are written in base 2. So, the first thing that it does is turn 2 into binary. The number 2 in binary is this. It's 1, 0. That's it. That means 1, 2, and 0 ones. So we see 1, 0 as 10, but to a calculator, 1, 0 means 2. Now we do the same thing with the second 2, okay? We're doing 2 plus 2, so it's 10 plus 10. So write that down. 1, 0, and then right underneath, write 1, 0 again. Okay, next, the calculator lines them up one on top of the other so we can add them. Are you guys ready to do that? Let's start on the right with the zeros. So let's do it right now. What is 0 plus 0? Right, it's 0. So write that down at the bottom. Okay, let's move over to the place on the left, the 1 plus 1. What is 1 plus 1 equal? It equals 10. Remember, in binary, 1 plus 1 equals 10. And we're about to learn why. So here's what you do. You write down the 0, and then you carry the 1 to the next place. So as far as we need to understand, it's 100 or 100. Now, does 2 plus 2 equal 100? In binary, it technically does. Are you ready to find out why? Okay. Here we go. Let's put this in base 2, okay? So remember, underneath the first 0 on the right, write the number 1. Then underneath the second 0, the number in the middle, write the number 2. And then underneath the 1, write 4. Remember, this is how base 2 works, okay? Every place is twice the last place. So 1, 2, 4. Let's do yes or no again. Are you ready? For the 4, yes or no? Yes, because there's a 1 above it. Now, what about for the 2? Is there a 0 above it? Yes, so skip that one. And then what about the 1? Is there a 0 above it? Yep, so skip that one too. Okay, so we just have, what do we have? 4. 2 plus 2 equals 4. Hey, you just solved a problem in binary. Well done. You just solved a math problem like a calculator would. And that is how a calculator turns button presses into answers. Whew, okay, that was a lot. Good job hanging with me. I know that was all very complicated stuff, but it was really fun to learn about. Honestly, if all that you take away from this episode is that calculators use a different number system than we normally use in life, that it uses base 2 rather than base 10, even just that, most people don't even know that. So you know a lot more about how calculators work than most other people. Good job. Okay, let's have a quick quiz. When you press a button on a calculator, are you pressing a real number or are you closing an electrical switch? You are closing an electrical switch that is turning your button press into binary code that the calculator can understand. And what 2 digits does binary use? 0 and 1. And does a calculator understand math like a human? Nope, it just follows rules. Okay, here's a couple of true or falses. Are you ready? True or false? Calculators store every possible math answer inside them. That is false. It calculates in real time by following its rules. True or false? Electricity flowing inside a calculator can represent numbers. That is true. A lot of calculators use batteries, but you ever seen those kind that have the little solar panel looking things on them? They're kind of powered by the sun. Those are pretty cool. Would you rather have a calculator in your brain or be able to do any math problem on paper very easily? I would love to be able to do any math problem on paper very easily. I'm not sure how I would feel about knowing the answer to every math problem immediately as soon as I think about it. But it would be cool if I knew that if I needed to answer a math problem, I could just simply do it on paper. So I'll go with that one. This was by far the most complicated episode I have ever tried to put together. Trying to figure out a way to explain all of this in a way that made sense. That was hard, but hopefully you at least got a little bit out of it, and I hope that you had fun kind of learning about the different number system that calculators use. Base 2. The other episode that was very difficult for me to put together was the one I did about how escalators work. For some reason, I just had such a hard time wrapping my head around how an escalator works. So I'll put calculators and escalators together on a shelf and say, here are things that Josh has a little bit of trouble understanding how they work, but I worked hard and made sure that I understood it well enough that I could explain it to the curious kids. I did it. And now, hopefully, you understand at least a little bit better how a calculator works. Calculators aren't really solving math problems the way that we do. They're just responding to inputs, following rules, and then displaying the results of following those rules. Can you believe somebody invented a calculator? That's just crazy to me. Pretty amazing. What kind of question do you think we'll ask tomorrow on Curious Kids Every Day? I can't wait to find out. So until then, keep asking questions and stay curious, kids. And some of the kids in the Curious Kids Club have birthdays today. These two kids are turning 2 today. Chloe from Maryland. Happy birthday, Chloe. And Lena James from Florida. Happy birthday, Lena James. These kids are turning 3 today. Jasper from Colorado. Happy birthday, Jasper. And Samantha from Massachusetts. Happy birthday, Samantha. These kids are turning 4 today. Ellie from Utah. Happy birthday, Ellie. And Abby from Massachusetts. Happy birthday, Abby. These kids are turning 5 today. Johnny from North Carolina. Happy birthday, Johnny. And Naomi from Canada. Happy birthday, Naomi. Ezekiel from California. Happy birthday, Ezekiel. Jasper from New Jersey. Happy birthday, Jasper. And Maya from South Carolina. Happy birthday, Maya. All these kids are turning 6 today. Harry from Bendigo, Australia. Happy birthday, Harry. Tristan from Oregon. Happy birthday, Tristan. Miles from South Carolina. Happy birthday, Miles. Esme from Ohio. Happy birthday, Esme. Finley from California. Happy birthday, Finley. Nolan from California. Happy birthday, Nolan. Christopher from Maryland. Happy birthday, Christopher. And Aline from Arizona. Happy birthday, Aline. To all the grown-ups listening, if your curious kid wants their birthday mentioned on the show, please visit supportcuriouskids.com and join the Curious Kids Club. That's supportcuriouskids.com. See you tomorrow.